Okay, Shia is not there. So welcome guys, good evening all of you, and we are live now with the exciting problem solving session, and it's my third class today. So they both have some positive side and negative side because I'm a bit on low on energy, but I will try to do as much possible on energy as possible, and there are some exciting problems for you guys. So I'm really excited for this, and some people are not live. Let me just inform them that we have started the live session. Join now. Yeah, live. Okay. You must have seen in the group, Shamya has given Shammo has given a really interesting problem, on, I don't know if you have seen, guys, we will discuss that problem today. It's a really beautiful problem, and therefore I will not miss this opportunity to discuss this beautiful problem with you. So, yep, let's start. The problem which Shamya has given in the group. So let me write down the problem over here. So what is the problem? The problem is the following. He has given, okay, the problem is the following. So I will do it in two different ways. One using real answers, another using statistical ideas. This is the problem. So there are two sets of numbers. Okay, there are two sets of numbers. A1 less than A2 less than dot AM and B1 less than B2 dot BN. Such that summation of AI minus X, uska modulus ka summation, and summation of J, like the BI, uska like modulus of some minus X uska modulus of summation. If these are equal for all X, then we have to show that M is equal to N and AJ is equal to BJ. Okay, so let's do this problem now. So any doubts on understanding the problem, guys? Any doubts on understanding the problem? So Insha and Tanvi, these two people are here who are new, and welcome to Cheenta for your trial part, and Ram Gopal is a first class. So welcome. Yep. So welcome all of you, and all of you understood the problem, guys.
Thanks.
All of you understood the problem. Any doubts? So we have two sets of numbers, A1 less than dot AM and B1 less than dot BM. And so can you tell me that is a summation, guys? What is that summation of modulus of, what is this called? Can someone tell me? What is this I do? Any idea what is this called? Any ideas about what is this called? Yeah, what's called? It's called the mean absolute deviation. So in terms of regression, in terms of if you take a see in terms of statistics, it's actually in expectation of modulus of X minus A in some sense, where each of them are given 1 by N value each. So the weight. So that is the idea. It's like more absolute deviation, sum of absolute deviation. Okay, sum of absolute deviation. So it's like telling that there is a set, the set of numbers on the real number line. There is A1, A2 dot AN, AM, and B1, B2 dot BM, whatever the numbers are. Okay, and it's telling that for all each of the point, if you calculate this two, like the mean absolute deviation from these two sets, let's say these, let's mark this in red, and let's mark in red cross, whatever the numbers are. So it's telling that whatever number you take, if you take this mean absolute deviation, both of them will be equal. Okay, both of them will be equal. So that's the question, that's the idea. So now you have to tell that if this happens, if for all X it happens, we have to show that in fact the set is equal, the two sets are actually equal. So any ideas on how we can proceed? Any ideas on how we can proceed? Any ideas, guys? Yeah, means absolute deviation. Yeah, any ideas, guys, how we can proceed? Yeah, Tanvi, any ideas on how we can proceed this? Insha, Sneha, Polomi, Suryansi, Hemant, Tishika, Polo.
So we can start with considering this sequence. Like we can take A1 minus X and so on till the sum goes like sum of all A1 terms minus M times X. So we
Wait,
can
wait,
take
wait, wait.
from,
Sum of all A1 terms.
I mean not A1, sum of all AI terms minus MX times
MX, wait,
minus
wait,
MX.
wait. MX क्या है?
MX is the sum of since we'll be counting X M times, right? Because
Okay, but it's
right.
absolute. Okay, it's like it can be -2. So if X is less than AI, then you can tell it's like it evaporates the modulus sign evaporates. If X is greater than that, then modulus sign it's like gets like it's minus of like X minus AI
Yeah,
then. So how do you know which is what?
we can consider the cases and we
Okay, that's a good approach. But don't you think it will be a long process? Like it will be competitive. Okay, do you know any?
Uh,
Yeah. Any ideas? I guess. Ram Gopal, yeah. What's your idea?
so anyhow, you are considering the one point from one point, how each and every other point is distance is there.
Mm-hmm.
So it will be some multiple of the common value, right? Like if you consider the deviation as some value, each and every subtraction will be some multiple of that deviation.
Each and every. I didn't get it. Can you just come again? Each and every.
No, actually, if you take that x as some point, and you subtract each and every value of it, like there will be some multiple of some standard deviation or something, right? Each and every subtraction.
The standard deviation will not come in over here. Why? Because there is no multiple over here. It can also cannot come because standard deviation in terms of squares. Okay, it exists in terms of squares. It's all about absolute deviation over here. You understand? So that may not be a good idea. But yeah, nice approach maybe. Hi Mihika, welcome to Chinta. So I hope you can hear me. So what a yeah, hi. Yeah, so Nijor Nath in the live session has told that we can write n as some m plus p and we can break the summation. That may be a really good idea. And maybe computing more computatively intense. But I have a question for all of you guys who are listening to this. Is that have you seen some results in absolute deviation? What is the beauty of absolute deviation? Can someone tell me? Like, if I ask you to associate one number with this absolute deviation, what comes to your mind? If I want to, like, I'm giving you hints, not giving you the entire idea. If I tell you, yeah, Bolo, any ideas?
Some median.
Perfect, median, very good. Who was this?
So Yash.
Yeah, hi, yes, very good. It's a median, lovely. So if it's a median, so how can you connect this median? Can you tell me? Can you explain it more, Yash, for on this?
so can we take the sum of all the terms like the middle term of both the series
Mm-hmm.
and then we can consider the GM sorry AMGM properties of them.
No, wait. You told about median. So where does the median
So
like
can we
go?
take X as median?
Ah, that's a good idea. Yash, that's a good idea. Yash, that's a good idea. So let's see how we can take the median. So what is the property? If I put x is equal to the median, what happens? What happens? Tell me. If I put x is equal to the median, what happens? Tell me, guys. What is the
So it becomes
property?
minimum value.
It becomes a
Minimum value.
minimum value. Lovely. So what is the result? So all of you guys know this result, or I will prove it now. It's like this. If a1, a2 dot am is a set, then the value f of x is equal to summation of 1 by 1 to m modulus of ai minus x is minimized at what? At what value? This is minimized at x is equal to the median of this set A. All of you know this result, or you need me to prove it, guys? All of you know this result or not? Insha, Sneha, Suryangsi, Kushal, Abhirav, Hemant.
So we know the result, but we do not know the proof.
Okay, yeah. Okay, who raise your hand if you don't know the proof, guys? Just raise your hand. It's okay. Like, okay, all of you know the proof. Please raise your hand. I will then understand the count. Okay, I will get the idea. I will share the idea with you. Let's try to understand when it's the minimum. So we will prove this, that this summation is minimum when it's the x is the median. Okay. Until now, let's try to understand. Okay, some people have some. Okay, you don't know the proof. Lovely. So I will share some graphs with you guys. Okay, I will share some live graphs with you. Let's stop presenting here, and I will share some live graphs with you. What exactly happens when I'll just share the live graph with the Desmos. What exactly happens? We'll understand this problem to the fullest. Okay, that's what our aim should be. So let's do the graph for the live session. I will also share the graph. The graph. Okay, so we'll understand the example via graph. So let's take 1, 2, 3, 4, 5. Let's take 1. So it's like modulus of x minus 1. So now understand where the minimum is happening at 1, right? We add. All of you can see the graph, guys. I hope all of you can see the graph. Good, lovely. So understand this. Modulus of x minus 1 plus modulus of x minus 2. From here to here, I think I should add this up here. So this was the initial one. This now changed to this. Now let's add another one now, the x part. You can understand that the structure of the graph will remain same. Okay, if I just change to 3 to 3.6, you say structure of the graph remains same. Let's do it for 3. Okay, to understand the what is really happening. Again, it's a minimum over here, and let's again add it. We'll understand the pattern now. What is really happening? So this is what is happening. You see,
It's going up all the time.
it's going up. That is correct. That is totally correct. What else is happening? Something else is happening. Let's understand what is happening over here, where it's actually the minimum. Can you understand? So we are interested in the minimum of this function. So we must focus on the minimum. The minimum is 1 here. Here is the minimum is between 0, 1, and 2. Here the minimum is between at 2, in fact. Okay. Here the minimum is 2 and 3. So it's the median, right? For 1, 2, 3, 4, the median happens between 2 and 3. Any number between 2 and 3 is the median, right? So do you understand now that it happens at the median? Now we need to prove it. How we can prove it? Can we prove it using we can prove it in 2 different ways. So we can show that in fact for the median it is decreasing, for the for all the x less than median it is decreasing, and for all the numbers greater than median it's increasing. Okay, and then the function is increasing. The slope is positive. All the slopes are positive, and for all the numbers for all the x less than median the slopes are negative. We can show that. Okay, maybe we can show that. Okay. But there's another way of approach using intuitions and approach and mathematics. So that is what we're going to do now. And in fact, we'll apply that same method to solve the previous problem. I call this strategy deletion strategy. Okay, deletion strategy. So let's see what is this strategy. How we can use this strategy to solve this problem. Till this point, are you understanding where you're approaching? Any doubts till this point? In the meantime, I will change my screen. Any doubts? No doubts, I guess. Okay, so coming back to the problem. Let me share the screen for this live session. So let's try to understand. Let's try to do it for 3 numbers, guys. Okay, instead of 2 numbers, let's do it for 3 numbers: A1, A2, A3. A1, A2, and A3. Let's do it for 3 numbers. So understand this very carefully. X minus A1 plus x minus A2 plus x minus A3. So let's say there's an increasing order. Let's say this happens. So they are like this: A1, A2, and it's just like 1, 2, and 3. Maybe you can assume that. 1, 2, and 3. Maybe you can assume that. So x is any number over here. So we are looking for the deviation, right? So we are looking for the minimum deviation. X is number over here. So it's the distance here, it is the distance here, it is the distance here. X is a number here. So what we will do is that we'll understand what happens if we put x is equal to a2, let's say. If we put x is equal to a2, it happens that this is the distance. This, that a1, a2 is the distance, a1, a1, a3 is the distance, ab is the distance. Now what happens if I change the point? If I change the point to left hand side of this, let's say here, then the distance, sum of these two distances becomes same, but this distance become larger, right? This distance becomes this plus this, right? Similarly, it happens on the other hand side too. So it's sort of around 2, around a2 is the minimum happening. So if we can show the rest of the point scale, it is actually greater than that point, then it's done, right? It's done. Any doubts? Any doubts till this point of time? Any doubts?
Please repeat the last thing, sir.
Sure. So for this point, if I, let's say for a2, what we get, the sum is what? This s is what? For x is equal to a2, the s is what? S is equal to ab, the length ab, right? Can you just check it? Because put x equal to a2, it's a1 minus a2, this length plus this length. All of you got it this point? Now we will understand for x is equal to a2 not equal to a. For x is equal to a2, for x lying between a1 and a2, what is really happening? It's happening that this sum plus this sum, like this sum plus this sum, let's say alpha, beta, and here it's gamma. Let's say these are the distance. So it's happening alpha plus beta plus gamma, which is happening equal to AB plus beta is the extra part. It's greater than AB, right? In fact, if you put it on this side, it will turn out to be the same. Now did you understand, guys? Did you understand it now?
Yes, sir.
Mm-hmm. Yeah.
So, what you did AC equals to AB, and then I didn't got it actually this section.
Okay, I will prove it again. So let me rub it off. Let me rub this off. We get the following, guys. We have this line, this is a2. So we take 2 points, one this point and one, let's say this point. Let's say these are distance alpha, beta, and this distance is gamma. So what if we put x is equal to a2, what happens? We get modulus of x minus a2 minus a1 plus modulus of a2 minus a2, which is 0, plus modulus of a3 minus a2, which is, so therefore this is what? This is equal to alpha, this is equal to 0, and this is equal to beta. That means the length is coming out to be AB, right? If you take x is equal to, let's say here, the star position, what we get? Star minus a1 plus star minus a2. This length is coming out to be alpha plus beta plus star minus b minus a3. So what is this? This is turning out to be what? Alpha. Sorry, this is a1 minus a2 is, sorry, it's alpha plus, yeah, alpha plus beta it will be gamma in terms of previous idea. So here x1 minus a2, a1 star minus a1 is what? Star minus a1 is alpha, star minus a2 is beta, and star minus a3 is what? Beta plus gamma. So we are having AB plus beta. Now you understood?
Yes, sir. Now it's clear, sir.
Good. So this is what we have now. This is what we have now. So therefore, similarly, if you take all these points over here, you will understand. If you take all these points here and here, you will understand it is minimizing here. If you take all these points inside of AB, it's minimizing at A2. Did you understand this point? Similarly, you can vary this point star over this between AB. Did you understand, guys? Any doubts? If you now vary the star between AB, the same proof will happen. Only alpha, beta, and gamma will change. Did you understand, guys? Now, clear, guys? Yeah, right. Clear in the
Yes.
comments. Good. Lovely. Now, what we will understand is the following. We'll understand outside this what happens. This is AB over here, and let's say this is A1, A2, and A3. For outside star, this length is there, and understand this length and this length. This length is entirely greater than AB. You understand this? This length is entirely greater than AB. The star something plus star minus A3 is there now. So which is greater than AB? So the entire thing is greater than AB. Did you understand this now? The entire thing is greater than AB actually. But the minimum value you have got is AB, right? The minimum value I've got is AB. So A2 is the minimum. A2 ke liye the sum is the minimum. Did you understand now? For this proof of like 3 cases. Tejas, Polomi, Trisaja, Obiru, Insha, Sneha, Mihika, Tenvir, Suryansi, Ram Gopal. Everyone clear, guys? Good. Lovely. So now, we will understand this for a general framework. We'll understand from a general framework. Let's do it for 5 numbers because it will become much more complex now. Why I'm taking odd numbers? I will tell you the reason, okay? But there is an elegant solution towards it. I will understand this. This is how you do the elegant solution. You find out the elegant solution, guys. Let's say this is A1, A2, A3, A4, and A5. Now, someone give me an idea using the same approach how we can do this problem. So you know this will be the minimum point. So for this, you know what is the minimum point. So how can you approach this problem, guys, for something other than that? Can you give any ideas? Tell me. Can you give any ideas? Hmm?
Whatever you showed earlier for less number of points does make sense here also, right?
Here also, but here the algebra must be much more advanced, right? You need to do a lot of equations. Can you bypass it? Can you bypass this? Did you see some pattern in the proof before? That's my question is to you. So what is happening? It's happening that if you take what is happening? Anyways, if you take points outside, guys, I don't know what
They are of no use.
they are of no use. Can you prove that mathematically in general case? Let's say there are n places. Okay, can you prove it from here? That actually they will not be of any use. They will always be greater than some point inside. Can you prove that somehow?
Yeah, we can prove by using the distance. Manhattan distances.
Mm-hmm.
We can say that if we consider the last point and anything outside the what do we say bound, so that will be always greater than the Manhattan distance from the bound to the last point.
Okay, let's do it. So let's say A1, A2 कुछ points है यहाँ पर. Let's try to understand what I think it's Tanvir, right? Or Yash? Huh. Okay, Tanvir, yeah. So let's understand. Let's try to mathematically formulate Tanvir's idea. So he's telling that first claim is that outside points are always bad. Outside points are always bad. So how do you prove that mathematically? Let's take any point here. So outside points are always bad than inside points. How can you prove it? So let's take this point, or let's take this. Let's take any point inside B. So B is a distance. So how can you prove it, guys? How can you prove it? Tell me, Tanvir. How can you prove it now? Which one is, yeah?
So is this so you're asking for the distance A not to B and the ambiguous.
So let's say A is the point and B are the points. So these are the 2 points. Compare these 2 points ka distance. How will you prove it?
So we can consider that the modulus of since A naught is less than B,
Mm-hmm.
no, yeah, A naught is less than B, and something minus A naught will be, no, I can't say it's great. It's always good, right?
Yeah. So think about it a bit. I will give you 2 minutes to think about it. Think about it. Yeah.
Can it be like this? Like you consider you have 2 points A and B.
Mm-hmm.
A is outside the range and B is somewhere in between. So can you consider the rightmost point as some variable you represent it, and then take the distance of the rightmost point with respect to A and B, and if it is less than the total less than or equal to total distance, then the point should be within the line whatever you've drawn. If it is greater than, then it is you can prove it like that, right? The line you have drawn, the distance, if you take some point within the line, if you take the farthest point, then take the distance, it will be less than the length of the line.
Mm-hmm.
And if you take some point outside the line and take the distance of the farthest point, it will always be greater than the length of the line.
Yeah, it's simple that you understand that the distance from this point to this any line is always greater than this point. Okay, this point ka distance from that point. So the idea, let's say it's called A1. So let's say it's any x over here. So any out of this x. So since A1 is the smallest, summation of A1 minus x minus A point, sorry, is greater than summation of AI minus A1. Why? Because this is this distance, this is equal to this distance, A1 minus A plus A1 minus that point, any other point. Okay. Did you get that? So any other point over here, I will write it over here again. Let's say x is point. So modulus of A1 minus x plus modulus of A1 minus A is actually equal to modulus of A minus x. Do you get this? So A minus x ka point is always greater than modulus of A1 minus x for all x.
Yeah, I was considering the farthest point, but with every point, this is the case.
Yes. So it will be working bad. So this is a better point. This is a better point. Okay. Similarly, coming from here, this is a better point. You understand? Coming from the left hand side is also a better point. Did you understand, guys? Any doubts? All of you understood in the live session? So we have got that. Understand very carefully. We have got that the furthest point A1 and AN works better than any point outside the line. So the required point must lie inside AB, right? The required point must lie inside AB. This is very natural. So what will be the next step? Think about this now. What will be the next step? So therefore outside points are bad. Now Now this is a very interesting, this is the most important step in fact. Let's take this second point, and this is this point. Let's take any point out here, x, and let's take any point out here, y. So understand that modulus of x minus a1 plus x minus a2 dot dot x minus an is का sum, and we'll compare this sum and a1 minus a1 plus a1 minus a2 plus dot dot a1 minus an. Can you tell me which one is better, which one is greater? Can you tell me which one is greater? Any ideas? Which one is greater? Which will be greater? For x, which will be greater? So what is this length? X minus a1 plus x minus a2. This length is a1 a2, right? A1 a2 plus a distance. What is this length? A1 minus a1 plus a1 minus a2. This length is again a1 a2, right? So what is happening? What is happening?
Sir, why it is so?
Just compute, na? Take any point x between a1 and a2. Okay. Then the distance x minus a1, x minus a2 is distance is same as a1 a2. Do you understand this point?
Yes, it's like one set one, like 1 2 3 so we are going from 1 to 2 to 3.
Perfect.
And that is same as 1 to 3.
So what is happening over here, guys? So therefore, yeah, I will just come back to so both of this. So let's take the first one is what? The first one is a1 a2 length plus x minus a2, x1 minus x minus a3 plus dot 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 x minus an. The second one is what? The second one is also a1 a2 length plus a1 minus a3 dot 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 a1 minus an. Now we have to minimize this. We have to understand which is greater. So it's sum is same. So what is happening? Try to understand the diagram now again. Is that a1 is here, x is here, a2 is here, dot an is here. So now understand that minimizing this two, like understanding which is minimizing this two is same as minimizing what? Minimizing this one, this set. Since both the distance are same, minimizing this two is because both the distance is a1 a2 plus this term. So minimizing this is same as minimizing with respect to the rest of the points, guys. Did you understand this part? Exactly, Hemant. Lovely. So essentially, this outside of the point we can ignore. Because we are minimizing with now respect to a3 dot a4. So we are now minimizing with respect to a3 dot a4. This points dot an. Because a1 a2 is constant now. Do you understand now? Do you understand now, guys? Any doubts? Will I explain that again, guys? Tell me yes or no. If I want to explain that, like if you want, I will surely explain that again. Tanvi, did you understand? Or will I explain that again?
Yes, I understand.
Mihika, Insha, do you want to explain? Do you want me to explain again? Okay, sure. So let me. This is a very critical idea. Okay, try to understand. This is one of the most beautiful idea and a critical idea. So what we have understood in the beginning, कोई भी set of points है. So we have the first idea is outside points are bad. Okay. So now let's take x inside. Let's take x to be inside a1 and a2. Let's say. Then what is happening? This is happening that sum is happening x minus a1 less than equal to, okay, less than equal to. So for x between x1 and a1 and a2, this is happening this, that it's x minus a1 plus x minus a2 plus x minus a3 dot dot x minus an. So what is this? Can you tell me? This is actually, this sum is, since x is between a and 1 and 2, this distance is what? This distance plus this distance, that is a1 a2 for all x. Understand this, for all x, plus modulus of x minus a3 plus dot dot xn. You got this right? Right? So therefore understand here that what is happening, this is same as a1 a2 plus x. Now what is x? X is actually outside here. A3 यहाँ से start हो रहा है. So x is actually here. You understand? X is actually here. So what is happening? This will not be a good point because again,
So there is no use of it.
It is outside the range.
it's outside the range again. So outside points again. So essentially it's equal to what? It's equal to a1 a2 plus against sum of the deviation of the set a3 dot dot an till an. Understand this? So it's sum of the range. So this is therefore not the minimum. So what is happening? It's happening that x, from the first case, you have got x must be less than a1. Outside points are bad. Now understand that if we remove a1, the sum will be essentially the same. Like, it's essentially speaking that we need to minimize this now, okay, with respect to x. So this cannot happen. This cannot be a good point. This cannot be a good point to minimize this number, right? Because it's outside that range of a3 dot dot an. This cannot be a good point. So what we do, x again comes here. So we keep on entering. And also on this side, understand this also keeps on entering here. This also keeps on entering here, the possible value x, and that will only meet in the middlemost region. That is the median. Only there is a minimum value. Did you understand the idea? Did you understand this really beautiful idea? Suryang, are you understanding? Follow me. Mihika, Hemant, Tejas, Sitreja, Ramgopal, Sneha.
Yes, sir.
Suryang, did you understand? Yes or no? Ovidup, did you understand? Good. So this is the beautiful idea. This is a beautiful idea, okay? Yeah, Parag, we take this is important for CMI data science also, Parag, okay? So this is a basic computational perspective. So this is what happening. So outside points are bad. So it turns out if we take it inside one step, it becomes outside points actually, minimizing with respect to outside points. And again, we remove the, so it's we remove a1 and an on the other side and we minimize it now. It becomes outside points. It becomes, so we keep on minimizing till we get into the middle position. That is the median. So this is a call like law of, like, you know, we are decreasing till we get a point. Okay, so this is this is a really beautiful idea. It doesn't involve too much of mathematics, but it just intuition, okay? Basic intuition, basic numbers. Okay, so coming back to this problem. So this sum is minimized at median. And that sum is minimized as median. Right? So it keeps on decreasing and minimizing median. So now, what's the hint for this problem? So that's a hint for you, this problem. Can you use this as the hint to this problem, guys? Can you use this as a hint to this problem? I will give you some minute to think about it. Can you just use this as a hint? Any ideas? Two functions we have to, they are equal. Fx is equal to gx. Then what we can say? If two functions are equal, the minimum value will be equal.
Yes.
So what we can say, guys?
So both are same medians. Maybe.
Yeah. Wait a minute. So we have got that fx is equal to gx. So what we can say, their minimum value, say x naught is the minimum, x naught में इसका minimum value हो रहा है and x1 में इसका minimum value हो रहा है. They must be equal because the functions are same, right? Can you understand this simple point, guys? This is the best idea. So if there are two functions fx and gx, try to understand. I'm repeating again. If two functions fx and gx, so the point, they are equal functions. Okay. Therefore, the points of where their minimum is happening, that set must be equal. Do you agree with me or not? If you agree, please write an yes. So I will tell you. Good. The minimum point is x. So what is the minimum point? So therefore, the median set, what do you get? The median set of a1 to an is same as the median set of b1 to bm. There's a hint number 2 to you. So now, can you proceed towards this? Can you proceed now? This is the best hint I can give you. Now you can proceed. So we have got the median set are the median sets of this two. Let's say both are odd. Okay, let's say both are odd. So we have get the median ke liye, it's the value they are becoming same. So what we can do?
So if the sets are same, so can we consider that both have equal number of values? I mean equal number of set points.
Wait a minute. So just let me think. No, we cannot tell that. Why?
I mean the order might be the same, right?
Can you speak a little more loudly, Insha? Yeah, that may be a good idea. That may be a good idea. But understand something. If m is odd, then the median is 1. Then there is only one median. And it implies that left hand side must be also in a 1 median. So n must be also odd. Do you agree with me? If n is even, then n must be even. So there are two cases, guys. Try to understand this. So I'm trying to make all possible ideas to you now, giving all possible ideas to you. Try to understand this now. That we have got the median set of a1 a2 dot am is same as the median set, the median of b1 dot bn. So it must be an interval or a single number. Similarly, it must be an interval or a single number. It's an interval if it's even number, m is equal to even or n is equal to even, and it's singleton if m or n is equal to odd. So since they are equal, they must be either both odd and equal at the odd or even at the same time, right? You understand this? All of you are agree with this? All of you agree with this? Ram Gopal, Suryangsi, Mihika, Tanvi,
Yes.
Sneha, Sriteja, Obirup, Tishika, Hemant, Tejas, Polomi. Agree with this? Good. Lovely. So we have that m. This must be even or odd. So let's say they're equal like this. Then what will happen? So we know that these two endpoints are those points. So therefore, in fact, two numbers are being equal. So we know that endpoints are equal. We know the endpoints must be equal. And endpoints are those points. Let's say AI and AI plus 1. And here BI and BI plus BJ and BJ plus 1. So AI must be equal to BJ and AI plus 1 must be equal to BJ plus 1. All of you got this idea? So what we have got? We have got that this function is equal to like this. Let's say a1 plus dot dot dot. Let's take one number, x minus a m minus 1 plus x minus. So understand this one term is coming out to be equal. So we can delete that. That is a common part, right? Do you understand this point now? We can now change fx is equal to what? Fx is equal to this common part plus say px. And similarly, this gx is equal to the common part because both the numbers are same plus some qx, right guys? Do you understand this part now? Do you understand this part, all of you? So we have that common part since one of the medians are equal.
Please explain once again.
Sure. Let's say x minus a1 plus x minus a2 plus x minus a3 is equal to x minus b1 plus x minus b2 plus x minus b3 plus x minus b4 plus x minus b5 say. Let's say this is the idea. Now we have understood that a2 must be equal to b3. We have got that since they are the medians. So what is happening? It's like x minus a2 is also here and this is also x minus a2 since b3 is equal to a2. So therefore this will get cancelled, right? Did you understand this now?
Yeah, understood.
All of you understood this now? Any doubts now? So what we will have, the new function will be what? X minus a1 plus x minus a3 is equal to x minus b1 plus x minus b2 plus x minus b3 b4 plus x minus b5. Now what we will do? Same idea. Tell me now what we will do. Mihika, tell me what's your idea? What we will do now? Same exact idea, guys. Any ideas, Mihika? Any ideas, Tanvir, Insha, Sneha, Ram Gopal, Suryangsi?
Again, we can say that the median A1 and A3 should be equal to B2 and B4.
Lovely, lovely, beautiful. So therefore, what we have, we must have this sequence. Therefore, we must say that A1 must be equal to the median of this must be equal to the median of this. So what we are happening? We are deleting every single time. So we are getting two numbers equal or one number equal. We're deleting that both numbers. We're again comparing the medians. So every single time we are getting two numbers or one more than two numbers equal, and we are deleting the set. So ऐसे करते करते one time both the sets must be over at the same time. Otherwise it doesn't make sense, right? So both the elements must be, both the number of elements must be equal, and both the all the elements are deleted and equal, right? So therefore the set must be equal. Did you understand now? Suryangsi, Tanvir, Mihika, Ram Gopal, Insha, Sneha, Sriteja, Birup, Hemant, Tejash, Polomi. Thank you. Very good. So that is the beautiful idea. So therefore the problem is solved. It is this we solved by, yeah, bolo Tanvir.
सर अगर हम बोल रहे हैं कि मीडियन सेट ऑफ ए एंड मीडियन सेट ऑफ बी आर इक्वल,
Yeah.
when we consider the sets to be equal, we already consider that the orders of the sets are equal and the elements of the sets are also equal. If I'm
No.
not wrong.
No. So understand me, we just like we are considering median of set 1, 2, 3, 4 is equal to median of set 1.1, 2.1, 3, 4, right?
Okay, I got it. Okay, I got it. Sorry.
So now understand we are deleting the 3, 3. So we are now telling that again the median of the new set is equal to the median of the new set. Now it's not equal unless they're equal. So every single time we are deleting the median, one number is turning, one or more than one or two numbers are turning out to be equal, and we are deleting them. And we are seeing the median of the next set. And we keep on doing it until we are out of the elements. So it can only happen if both the sets are equal and their number of elements are equal. That's the only thing. It's a long problem, you see, it's a really long problem. And this problem, so this second problem, the first problem I discussed, it came in ISI BStat, okay? And the second problem I discussed came in ISI MStat, the bigger problem. Okay, so these are the two beautiful problems, and this is how you must write it, as I have told you, step by step. That good points are bad, and then you use an induction idea, like not induction in some, like it's called backward induction. So it's like what you do is that you use the same idea backward again and again in a recursive format to get to that final point till you get that point, till everything is cleared. And then in this last case, what we use that we reduce the number of elements till it goes to 0. That's why we get this idea. So any other questions, guys? Or I think there is not much time left, so we can leave the class. Or I don't know. Let's
Sir,
see.
1 minute. Sir, can you please make us go through once how did we cancel out those terms? Then x minus a1 and x minus a2 and b3.
Sure. So we have this one and we have this set. So we are what we have told that this is minimized at the median, that is a2, and this is minimized at the median, that is b3, and both the medians are the same. So a2 must be equal to b3. So we put, therefore these two functional terms are equal, x minus a2 and x minus a b3 are equal. So we cancel them out from the equation because these two functions are equal.
Yes.
So therefore we get x1 minus x minus a1 plus x minus a3 is equal to the rest of the term. Now we create.
So for the every subsequent set, we find the median and cancel out those medians.
Exactly, and everything, and it will only happen that it will cancel out smoothly only when all the sets are at the fine every like at every single step both numbers are equal, that we know. And at the end of the day, like, it's not like, if you now understand this, suppose in this case now you do the same second step over here, a1 must be equal to b2 now and a3 must be equal to b4, so you cancel them again out here. But it turns out that x minus b1 plus x minus b5 is equal to 0, which cannot happen. So therefore equal number of elements must be there. So that's the first step to prove, equal number of elements must be there. Now once we prove the equal number of elements, we tell that we are deleting either one element or two elements at a time, and every single time we're deleting one or two elements, and at the end we will be deleting all the elements together, and all at by the previous steps all the elements are equal after we have deleted. So all the elements in the two sets are equal. So hence all the elements are equal, and or like all the two sets are equal and the number of elements are equal. This is how you should, like, this is the approach, guys. Hemant, can you unmute yourself and tell me what's your doubt?
So in the first equation, when we add all the terms, we first said that x is the median of ai's and median of bi's, right?
No. It's a function. Understand? Fx. It's like fx is equal to gx. Okay. So both the functions on two sides looks different. So what we do is we know that fx is equal to gx. So what we do now, if fx, two functions are equal in two different formats, it's like telling that it also implies that the minimum of fx is equal to the minimum of gx, the point where the minimum is happening, right? The argmin, I mean. So therefore it turns out that median is also same. Yeah. If the points where their minimum is not the same, then the minimum will happen at different points. You can understand from the graph that it will be different. Like the graph will be different and the function will be different. So that's the idea. Okay, everything clear now? So it's a long problem. I decided to discuss one problem today. Yeah, Parag, is class 12 maths book enough for maths part in a CMI Data Science? I think yes, it's enough. You can do another maths book called Pre-College Mathematics, which do some theory of equations and polynomial stuff, and the combinatoric stuff, which is not there maybe in the board's book. But yeah, and yeah, I think that's enough, Parag. Okay. So let me see. What else can be there? So I want to end the class with a question now. Let's say here, see, it is happening, you know why? Because the elements are turning out to be one of the elements of the set. So can you find some other loss function? So it's like telling, it's like telling this. We can also understand this problem probabilistically in this sense. X takes values a1, a2, dot an, each with probability 1 by n, uniform, discrete uniform. And y takes values b1, b2, dot bm, each with probability 1 by m, discrete uniform over this set. So now expectation of modulus of x minus a1, x minus t. Yeah, someone was telling something. I think Insha was telling something. Yeah, exactly, Shamya. So that is the idea. I knew that. Yeah, I just, as I saw you have given the real analysis approach now, I thought that I should discuss this problem. So this is problem suggested by one of our like eminent students here. So in the group, Samya. So he has given this problem. So he has given the solution using real analysis. So real analysis, Samya will give the solution using real analysis in the group itself. So I will not discuss that. I will leave to Samya, because these points, as you have seen from the graph now, these points are the non-differentiable points. So all A1, A2, A3. So therefore, the set of non-differentiable points are like their set must be equal. Otherwise, their function must be like different. So that's why I didn't share that. But yeah, that's also a nice approach. But I will do it. I will leave it to Samya to share the solution. Yeah, Insa was telling me something. Can you come again, Insa? Okay. So this is like expectation of the loss function of x minus t is equal to expectation of the loss function of y minus, like this is the idea for which t is minimum. So in this case, these two are equal actually. So does it mean that it turns out that x is actually samely distributed as m? It can be in exam, it can be given in this question, this format also, okay? So remember this. In exam, it can be given in this format. Expectation of the absolute loss function is this. Prove that x is similarly distributed with y. X and y is actually same. Now I give you a homework whether you can prove it using some probabilistic approach or not. Think about that. Whether you can use some probabilistic approach. One is real approach. This is normal argumentative approach using normal mathematical ideas and basic mathematics. This now understand whether you can prove it using probability ideas or not. X is same distributed as y or not. Think about this problem now. Okay, whether you can do it with. I believe it can be done. Okay, Samya, also you try it. Okay, so I think it's a really good problem to try. So all of you understood this problem. X, if expectation of x minus t is equal to expectation of y minus t. So think about this problem now, whether they are same distributed. I think that will be the same, but I think there is a better solution out here using probability. I feel that somehow intuition tells me. I don't know. Okay, so thank you guys for your time, and I hope you enjoy the session. It was only one question, but we discuss a lot of different ideas and approaches, and that's the beauty of this problem solving session. We go a little bit out of our zones, comfort zone, and discuss long term problems. So when you are doing this is the mentality. I am only one focus for this problem solving session, guys, to develop your attitude for solving long problems over time, so that you are getting prepared for ISI MStat. If you don't have the temperament, then I think ISI MStat is not for you. So from this session, understanding your temperament in this session, you will understand, or maybe if you're in a good mood, I am not telling you whether maybe it's a very bad time coming. So if you're in a good mood and if you're in a present mood and you feel like you are not like coping off this with this session, then I think you should like try to attend and do this problems for a long amount of this session. Okay, I think this is really important to build your temperament, because solving these long problems in ISM study is really important, and writing down this problem is even more. It's not objective. So, okay, all the best, guys, and I hope to see you in the next class too. How to increase speed in long questions of ISI, Hemant? One is practice, practice, and practice. Write down the solutions, Hemant. The problem is when you cannot write down the problems, is that how to express yourself. That is the one problem you face, Hemant. So what you do is that you write down. As I always told my students, always write down the problems, okay, the solutions in real format. Whatever, if I have discussed this problem, write down this problem now after the class in real format, okay. In whatever you will write in exam, you will understand that I have not written all the proofs, okay, so that you can read between the lines. When you will write this solution down, you will see where I have missed those points deliberately. So try to fill those points. You will understand how to write the problems of proofs. It is really important for ISI MStat. That's how ISI MStat like turns out to be different from all other exams, okay. ISI ka koi bhi exam turns out to be different. So all the best to you guys, and see you in the next class. See you in the next session. Good night and stay safe, please. So all the best. Bye bye.
When will be the next